let's have a look at this. So what I want to kind of get you thinking about here, we're going to move on the next section, 6.4, right? We're in module 6, and this is a big module. There's a lot going on.
Right.
In section 4 is a big section. Section 4 is about factoring polynomials. Okay, but before we jump into factoring polynomials, I want to put this into some context because think about why it is that we factor stuff, right? We do a lot of factoring in algebra, and that's kind of like, what would it be like? It'd be like in English, you'd be learning grammar or something, so you can be a good writer, right? You're just learning some skills that you're going to use to actually do something, which is solve equations. That's why we factor. So if we go back to this one, let's just think for a second back about how we solve quadratic equations. This is not, it ends up not being a very hard one, but the easiest kind are the ones where there's a single x that we can point to. For example, what if you had one like this instead? What if you had something like 2x squared minus 18 equals 0? That's a really easy one, right? How come? Well, it's easy to do because this is one where there is a single x, and whenever there's a single x, what can I do? I can do some stuff, but I can isolate it, right? So what are the steps in order that I would have to do to get that x by itself? That's not what I do first, though, right? Because if I want to know the order, yeah, good. I've got a reverse PEMDAS, right? So first I'm going to add or subtract. So first I'll add 18 to both sides. Then what? Divide by 2. Then I get x squared equals 9. So then what? Good, square root. So I'd get x equals, okay, but what do I have to always do if I square root both sides? Positive or negative. Plus or minus 3, right? That kind's easy, right? Because all we got to do is just reverse order of operations, nothing to it. This other kind that we're doing up here, I guess you could think of as maybe being one step harder, because I can't just isolate x. But what are my other options then? If I can't isolate x, what am I going to do? What's that? Find magic numbers if I can't. Perfect. So I got two options. I could factor, or I could, if I can't factor, or if it's either can't factor or don't want to for some reason, then I can always do what? There's always an ace in the hole. I can solve any quadratic equation by using, what's that? Quadratic formula. Always works. It's always going to give me the right answers. But it's a little harder to use. I mean, there's more to it. If I can find magic numbers, by all means, use the magic numbers. So are there magic numbers here?
Yes.
There are. What numbers multiply to negative 28 and add to negative 3? Good. And then look how easy that is. Now this, we've done even more stuff than we had in Module 3 using factored forms of functions or equations. And so now we know, like if we were graphing this, where would the x-intercepts be?
Positive 7, negative.
Yeah, positive 7, negative 4, which I get from finding out when these are 0, right? Those are the x-intercepts of the graph, but those are also, therefore, those are the real solutions then, right? The real zeros of this equation. So we'd end up with either x equals 7 or x equals negative 4, right? And we just got there by factoring. And look what the factoring did, and what it always does. It takes a hard big factor and breaks it into smaller ones that I can set equal to 0 and solve more easily, right? We didn't have to do it there. It just was easiest. But what about with something like that? Okay, now I don't have a choice because this one is no longer a quadratic equation, right? Now it's got the highest power of x is 3, and so it's a cubic polynomial, right? There is no cubic formula, like there's a quadratic formula. So we have to factor this if we're going to solve it. So for example, let's say that's our goal is we're going to, we've got this set equal to 0 and we want to solve this equation, then I've got to factor. Well, the first thing we always want to try to do, and we talked about this earlier, but we haven't done very much of it, is we want to see if we can factor out a greatest common factor, right? And let's break this into the variable part, which is the easiest part, and then the number part, which is a little harder, but it's not bad. So is there, I mean, notice that all of these terms have an x in them, right? What's the biggest power of x that I could undistribute or factor out, same thing, from each term? 1. Yeah, it is, it's 1. And it's always just gonna end up being the wimpiest power of x, right? We would call it the least common factor, or least common power of x. Meaning, if I've got an x cubed and an x squared and an x, well, x is the weakest power, so that's the one that I can factor out, right? So if I undistribute or factor out an x, does that make sense that that's what we get? Okay. How do we get these terms here? Well, all we're doing when we factor something out, we're just dividing it away from each of the terms, right? So we'd say 6x cubed divided by x is what? Well, x cubed over x is x squared, isn't it? Right? And x squared over x is x, and x over x cancels, right? Okay, now there is another part to this. That's the easy part. It's always going to be pretty simple. What about the numbers? What's the greatest common factor of 6, 15, and 6? What do you think? What's the greatest common factor of 6, 15, and 6? What is it? 3. Yeah, it's 3. So I could also factor out a 3. Well, 6 divided by 3 is 2, right? 15 divided by 3 is 5, and 6 divided by 3 is 2. So that's what I'm left with, right? And that's pretty good. When I get to this point now, now I don't really have to go any further, do I? Technically, I could go a little bit further, but I don't have to, because now I've got this down to where, how many factors are there? Keeping in mind that factors are the things that are being multiplied. So how many things are being multiplied on the left there? 3? Which one? Now, are you counting the 3 as being something separate? You could, I guess. But we could just do this, couldn't we? We could just say I've got 3x times that whole thing. How do I know that that's one thing? It's in parentheses. Right, the factors are the things that are either in parentheses or that I could put in parentheses, right? Did everybody see that that's really just 2 factors? Okay, we started off with one big factor, but now I've got 2 smaller factors. Do I have to go any further? No, because each of the factors is either quadratic or smaller. And if they're quadratic, I can set them equal to 0. In worst case scenario, use the quadratic formula, right? Okay, so what about these? Maisie, what am I going to get if I set this first factor equal to 0? What's the solution? In other words, what value of x is going to make that one 0? 0, right? Yeah, 0. Yeah. So x equals 0 is one solution, right? That's not an accident that it happened that way. Whenever you factor out a greatest common factor, that's a monomial, right? So nothing's being added or subtracted. It's just some power of x and some number. The solution's always going to be 0, isn't it? Right? Now, what about this one here? This one's a little tougher. We could factor this. It does factor, but because it's got a 2 in front of the x squared, we normally don't even want to try, right? So what are we going to do instead? We don't have to factor it because it's quadratic, right? So what if I were just to set it equal to 0 and solve? What can I do with that? I don't have to factor it. Quadratic formula, right? That's all I have to do. What's my value of A? 2, good. What's B? 5. What's C? 2. So then we can just say, okay, x equals negative b, so that's negative 5 plus or minus the square root of b squared. Well, what's 5 squared? 25. Minus 4 times a, which is 2, times c, which is 2. All divided by 2 times a. 2 times 2 is 4, right? Just have to simplify that a little bit. So I get negative 5 plus or minus the square root of 25 minus this. Well, what's 4 times 2? Times 2. So 25 minus 16 is what?
9.
9. Good. So all this stuff in here, this is really just a square root of 9, isn't it? And what's the square root of 9? 3. So I can just replace the square root with a 3. And on the bottom, I've got a 4. So that's both of my answers. All I've got to do now is just take the case where, okay, what if we take the plus sign? Then x equals what? Negative 5 plus 3 is what? Negative 2 divided by 4. So what's negative 2/4? Simplified. Negative 1/2. So there's one solution. What if we take the minus sign? Negative 5 minus 3. Negative 8 divided by 4. So there we go. I've got 0, negative 1/2, and negative 2, right? Those are my solutions. Okay, so that factoring out of the greatest common factor a lot of times makes this a lot easier. So what about this one? What if I'm trying to solve this one? It's cubic, right? What's the greatest common factor? Is there something I could, what's the biggest power of x I could factor out? X to the 1. Okay, so we could take out an x to the 1. What's that going to leave us with? 2 x cubed divided by x is x squared minus 20 x divided by x cancels, right? That's 1. Everybody agree? Okay. Is there a greatest common factor for the numbers? What's the biggest number goes into 2 and 20? 2. So I could also factor out a 2. And what's that going to leave me with here? Good. Well, how about here? 10. Okay, good. Right? And so now I've got this broken down, and I don't have to factor it any further because I've got, that's quadratic, right? And that's an easy one actually, isn't it? So if I set these equal to 0, Maisie, what's that one going to be? I'll go right back to you on this one. This is your specialty here. 2x equals 0 and x equals 0. Good. How about this one? We could set that equal to 0, right? So we get x squared minus 10 equals 0. So what am I going to do to solve that? Bailey, what am I going to do there? What 2 steps to get x by itself? Add 10. Then what? Square root. So I get x equals plus or minus square root of 10. So there's all 3 of them, right? If I wrote them all out separately, I'd have 0, positive the square root of 10, and negative the square root of 10, right? Okay, one more, and I'm going to let you work. How about this one?
3.
Okay, so I can take out an x cubed. Good, that's first step. Very good. So if we take out an x cubed, we're left with negative 2, what? X to the 5th divided by x cubed is what? X squared minus 12, what? X, okay, and then minus 16 and the x cubes just cancel. Okay, what's the greatest common factor there? 2. But remember, we talked about earlier in the year when we talked about in Module 3 about factoring out a greatest common factor. We always are going to factor out whatever the sign of the leading term is also, right? So we'll make it a negative 2. So we get negative 2x cubed. And now what's left? Negative 2 divided by negative 2 just gives me my x squared. Negative 12 divided by negative 2. Positive 6, and then negative 16 divided by negative 2. 8. Okay, and so if I were solving that now, how would you, what do you think? Quadratic formula? No, magic numbers. Yeah, what 2 numbers multiply to positive 8 and add to positive 6? Yeah, 2 and 4, right? So we could just break this up into negative 2x cubed, x plus 2 times x plus 4. And what are my zeros going to be? Ariel, what am I going to get for that one? That's 0. Negative 2x cubed is 0 when x equals 0. Okay, how about this one? Let's see. Lorraine, what am I going to get for that one? Negative 2. Very good. Jasmine, how about that one? Done. That's it, right? Okay. Good? All right. Have at it. You may work.
Are you putting grades in today? You promise?
I'll do it right now.